in your homework, you had a bunch of stuff that looked like this, and I'm just going to do one example. And yes, in the homework, I kind of filled in the blanks. I said this, every one of them I gave to you in this form right here. Right? I said, basically fill in the blanks. And please fill in the blanks. What goes here and here?
Hold on, sorry.
Okay.
3 over, so I guess it's plus,
Yep.
plus 3 over 2.
Plus 3 over 2 goes in there, and what goes in here?
3 over 2.
3 over 2, it's the same thing, right? First, outer, inner, last. Yeah, that's the last means. Now, okay, here's the thing. Now, a couple things to notice. All of the information, given that we have a 1 in front of this x squared term, it's really brainless. We could just say, well, of course, that is what that must be. That's really nice. So that's pretty much taken care of for us. And then everything else is entirely, all of the information is entirely contained in that one x term, right? And so now, let's not lose sight of what this means. This means that this entire thing is equal to this entire thing right here. In other words, whenever I see something like this, I could replace this with this right here. Okay? This, and how, so sorry, buddy, we gotta wait. Yeah. So let's just real quick, let's say that we had an expression like this. If there were some way, please do not, buddy, please don't do that. Thank you. Okay. If there were some way to add on to this thing right here, right? In other words, given this, if we could pull this out of the ether somehow and get it to right here, there was some magical way that we could just add that on somehow, then this entire thing right there would be equal to that thing right there. And in this case, we could then rewrite this as x plus 3 over 2 squared, because this thing is equal to that thing. This is a fancy way of writing that thing right there. Which, of course, in this case would be nice, because then we'd be able to do this type of thing, right? The square root of something squared is just whatever the inside stuff is, right? So, the point here is it's real, like the way the homework was set up. The way the homework was set up was you could lose sight of the big picture. The big picture is that we're going to have stuff like this, and it will benefit us to turn it into something like this. And so in every situation that you saw in your homework, there was one piece of information that was missing. And the idea is going to be, if we could find that missing piece of information, if somehow we could take our given thing and add that on, if it's that thing, then it turns out that this entire thing is equal to this thing right here. Okay, and now we've done the work to pretty much, you should be able to do this in your sleep now. Given something like this and this, you should be able to, this is what's called completing the square. Makes kind of sense, like, right, we're missing a piece, we complete it, and now we have a square. And so here's a question for you. Squared plus kx. What am I missing right here that would turn this into a square?
Well,
What did we do last time?
we divided it for 3 by 2, so would it be?
I couldn't hear you over that. What did you just say?
Can you hear me?
I couldn't hear you over the boy yelling.
Oh boy. So we we divided the middle number by 2, so would it be plus k over 2?
Plus k over 2, but something specifically
Squared.
Whatever that number is, squared. And so, given something like this, you could say, well, if somehow I can pull this out of the ether, then I could turn this entire thing into what?
Oh. Hold on, sorry.
Okay.
I was trying to write it down, but I wrote things in the wrong place, so it wouldn't make sense.
Okay.
On accident, so I have to recopy. So 3.
Okay, no problem.
Squared. Okay, equals x squared plus kx plus k over 2 squared equals x plus k over 2 squared.
X plus k over 2, boom, quantity squared. Yes. And if you're so inclined, you could, FOIL this guy out, and it should be pretty obvious. Like, right, first would be x times x, yes. Outer would be k over 2, inner would be k over 2. Half of a k plus half of a k comes out to 1k. So yes, that would come out to be kx. And then the last, that times that would be, well, I'm not going to calculate it out. I could just write it in shorthand like that. Yes, this is exactly equal to that bad boy right there. Okay, so that's the idea with the homework, right? And we're not simply filling in the blanks. What we're going to be doing is we're going to have something like this. And what we're going to say is, well, man, I could turn this thing, this type of thing into this type of thing, if only I could somehow pull this out of the ether, right? And in every case, we've seen this, it's entirely determined by this. Anything else that shows up in there doesn't matter. If we have an x squared by itself plus some number times x, then the number that we need, the only number that's going to work, is half of that squared. If we could somehow add that on, then that entire beast is going to turn into a form that we want. It's going to look like something we want. Okay. So, can I erase this?
Yeah.
Okay. So, now here, at this point, we're going to do a little bit of damage control. I said that our goal is to turn this kind of beast into this kind of beast. Right? And we saw last time, like, if you have something like this equal to 0, you could always solve for it. And that's nice. And I think that was even in your homework. You had some stuff that looked like that. And we found, like, yep, you could always find an answer. That's cool. But what I didn't say, and this is something that you might think, it's like, especially with the conversation that we had, it's like, wait a second, if we're trying to get this to be something squared, possibly plus or minus something. I guess we'll use k again. You might wonder why bother having that a on the outside, especially when we first started doing these. I just said like, well, here's x plus 2 squared minus 9 equals 0. And we went and we did all that kind of stuff. And it kind of seems like this a right here just kind of comes out of the ether, or like, why is the a sitting out front? And I don't know if you're like me, I might, my first intuition is like, well, what if we had the a inside? Like, it seems like I should be able to take something like this and rewrite it as maybe something like this, the square root of a times x plus a number like that. Well, because of this, and you'd have, when you square that out, you'd have root ax plus some number, plus some number. And when you do first, outer, inner, last, your first would be root a times x, and you would get the first thing that you're looking for. Root a comes out to a. X and x come out to x squared, and some other stuff, blah, 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 blah. And we might think, well, logic dictates that we take this route instead. Why don't we say, because this is, I say obvious, but it's like, this is kind of the way I would start with something like this. And it turns out that if you follow this path of logic, you will end up with a solution, and there will be a way of going about doing this. And you could stop there. But if you take one more step along the way, you'll find that all of the work you did to get it like this, turns out that if you take one more step, you'll end up right here. And it will actually be easier to just do this instead. My point is, I didn't really justify why we want that a on the outside, why in effect we want to factor out that a. But we don't have time to go down all of the different logical paths we can to end up here. But I'm telling you, they all roads end up with this bad boy right here. And it turns out to simply be much easier if you do factor that a out and have them on the outside. So that's a little bit of damage control in case you were sitting there wondering, well, Justin, why aren't we going down this route? Whatever. The idea is there are a bunch of different routes we could take that are perfectly rational to go down to turn this type of thing into this type of thing. And they don't necessarily have an a out front. But it turns out that if you continue down those roads, you'll find that pulling out that a will make your life a lot easier. So we might as well just do that anyway. So I just wanted to get that out there. And now, okay, now we can get along with the stuff. So I'm going to go ahead and erase this. This is, don't think about that anyway. So, factor. Let's just think about this. I'm going to get rid of all this, and we are just going to think back to when we first started factoring things out. And I'm going to ask you a few questions. Can I factor something out of that? And we're not thinking about the x's. The x's are going to stay put. Can I factor something out of this?
Yes.
What can I factor out?
A 2.
Okay, I pull out a 2, and what's left over? What's left in the first place?
X squared.
Plain old x squared, and then what?
Plus 4x.
Plus 4x. Okay. Let's do another one. Let's do this. Can I factor something out of there?
Yeah.
Okay. What can I factor out?
A 3.
A 3. So I have a 3, and then what's left over on the inside?
An x squared and a 2x.
X squared plus 2x. Okay. What about this one? Can I factor something out of there?
No.
Hmm.
Yes.
You can, but it doesn't look like it, right? Because you think, well, you can't, like, this is obvious, right? Actually, let me ask you, how did you get this 4? What did you do in your brain to get that 4?
Divided by 2.
You divided it by 2, right? So in other words, what you did here is you said, well, if I pulled out a 2, I would have this, and then I would have whatever 8 divided by 2 is. Right? And then you just said, because you've been conditioned your whole life to say, well, that means 4. And so you told me 4. You did the same thing here. You said 6 divided by 3 is 2. In other words, what you did was you said, well, 6 divided by 3 is 6 divided by 3x. Okay? Now let's just take a second and look at this. Now, I've said this a bunch of times, and this is going to be very important for what you're going to be doing with completing the square. I've suggested that every time you take a step, right? So like going from this right here, going from this down to this, that you do the opposite step to check yourself, right? So after I factored out a 2, I would say, okay, let's just make sure that this is equal to that. The 2 comes back in and gives me 2x squared. Good. The 2 comes back in and gives me 2 times 4 is 8x. Yes, good. So this is equal to this. What's nice about this is that this one's even easier to see. You don't even need to do any calculations really, right? The 2 comes in, hits the x, and gives you 2x squared. You're good. The 2 comes in, and what's really nice is by writing 8 over 2, you don't need to use your brain. The 2 comes in and gets multiplied. The 2's cancel, right? That's kind of what goes through my mind's eye when I see that. I see the 2 jump over, and they're gone, and I'm left with an 8. Ditto right here. 3 comes back in, kills the 3, and I'm left with a 6. I'm good to go. What do you think we could pull out? If I wanted to pull out a 3, what would be left over right there? Reason by analogy, by what we did here in the last line, what would be there?
7 over 3.
7
X.
over 3. 7 over 3x. Now, right now, I'm asking you, basically take a leap of faith. To go from here to here, we're going to call this faith. Right? Like I'm basically telling you to factor something out, you just divide by it. And okay, yeah, like you've told me a rule now that if I factor something out of this, I just divide by whatever it is. But what I'm going to ask you to do is every time you do this, just check it just in your head, and then you'll start to believe it, right? So in other words, to go back to this way as you're doing these, when you check it, that will lead to belief. So like I do this mindlessly and say, okay, if I factor out a 3 from a 7, I have 7 over 3. But now I could see, yeah, if I put this back in, I would have a 3 and an x squared. And then my 3 comes back in, gets multiplied by 7 over 3. Oh yeah, the 3's would cancel. And indeed, I would be left with this. And now I'm starting to believe this step that I took in faith. And indeed, this is going to work with every single number that you could possibly come up with. Is it easy to see now? Like, I mean, if you go from here to here, is that easy to see that, yes, those two things are equal?
Yeah.
Yeah, it is, right? Now, for your homework, it's going to get ugly. It's going to get real ugly. You're going to have some fractions that you're going to have to factor out. And like, for instance, here's an example. Let's say we have 1/4 x squared, and let's go plus 3x. And let's say I factored out a quarter, because that's going to be the game. We want to get that x by itself. That's what we're going to do every time. We're going to pull out whatever number that is. And what did I just say we do? We divide by that number. So we have 3 divided by a quarter. But when it's a fraction, how do we divide by a fraction?
We multiply by its reciprocal.
We multiply by its reciprocal. And so I'm going to say, well, that's the same thing as 4/1 times 3x right there. And actually keeping it in this form, it's real easy to see and check, right? Because this was the step of faith. Like, well, Justin said, I just divide by it. And I know that dividing by a fraction is multiplying by a reciprocal. And so I wrote it like that. Now let's check it. The 1/4 comes back in and gives me a quarter x squared. Good. 1/4 comes back in. Oh, yeah. 1/4 and 4/1. Yeah, they cancel out. Cool. And if I'm so inclined, I could go ahead and rewrite that as this right here. 4 times 3 is 12. The 1 does not matter. And now this is also easy to check, right? The quarter comes in and gives me x squared. Quarter comes in. 12/4 is 3. Yeah, okay. That's how we could factor out a fraction. Let's do one more with a fraction because these things are ugly. They're really ugly. And do you have all this? Can I get rid of it? Okay. So what did I want to do? It was 3/2. 3/2 x squared. And we've been using pluses. Let's do a minus. Let's do a minus 5x. Okay. I'm going to factor out that leading term or that leading coefficient, 3/2, to give me x squared. What sign am I going to have here?
Minus.
Yep. And now what?
Divide by or multiply by 2/3.
Multiply by 2/3. Okay, and now I could see, yep, the 3/2 comes in, kills the 2/3, and I'd be left with 5x. Okay, I believe that step. I guess we could simplify this a little bit. What happens when I multiply the numerators, and what am I left with?
10/3x.
2/3. There we go. And I could just double check again. The 3/2 comes in, gives me the 3/2 x squared. Good. 3/2 comes in, the 3's are gone. I'll have a 10/2. 10/2 is 5 minus 5x. Good to go. This means exactly the same thing as that thing. Good to go. Okay. One last one. Can I erase this stuff?
Yeah.
Okay. Suppose I had this. And I wanted to factor out an A. What would I be left with in here?
Hold on. A squared x equals x squared plus b over, or hold on, wait.
That first term.
Oh, x squared
Yep.
plus b over a x.
Yep. Now that was faith. Now let's check it and make sure that we're good. The A comes back in, ax squared. Yep. The A comes in, kills the A. The A and the A cancel, and I'm left with just a bx. Yep, bx. I think it's 10 times easier to go in the reverse direction. Like you could almost just see it, you know. And so I'm going to really stress that as we go along with, as you're doing all of these problems where you're going to be completing the square, every time you write down a new line, you stop and go, wait, A comes in, yep, A comes in, yep, okay, I haven't changed anything. This means exactly the same thing as that. I've just written it a little bit differently. Huh. I've written it a little bit differently, but it means exactly the same thing. This reminds me of something I said a little while ago.
Oh, great.
Yeah, we're gonna take a little detour. We're definitely gonna come back to this bad boy because look at that. This is almost the very thing that we're looking for, right? If I added a little plus C, and you could kind of see where this has been going, we could see that, that's all the information I need to complete a square. There's one piece of the puzzle that's missing right now. And so let's take a detour. I'm going to write something down. Here's an expression. A half plus a quarter. Now, for whatever reason, I may want to write this with a common denominator. And if I did, before we start, one thing to notice, this is not an equation. This is just an expression, right? Like, I don't have this equals something like this times x equals the square root of this. There's no equal sign here. We're just saying this is some number. This has a value. And what I'm about to do is not an operation on an equation. I'm not gonna add 5 to both sides or square both sides or something like that. There's no sides to anything. This is simply an expression. It's a number. And I want to manipulate it. I want it to look different, but I don't want to change the value. And what I want to do personally right now is get a common denominator. And I look at this and I think, well, if I could multiply this number right here by 2, I would have a common denominator. In other words, I want to multiply by something, but I don't want to change the value. What's the only number that I could multiply something by and not change its value?
Two.
Wait a second.
What?
I want to multiply it by something, but I don't want to change its value.
1.
1 is the only number I could multiply something by and not change the value. So I know that I want to multiply this. I can't change the value. And so I think, well, let's just start there. I'm going to take this number and multiply it by this. That way, I have not changed the value of this. Have I? Check me on that. Am I lying to you? Is this the same thing as that?
Yes.
Yeah, right. I mean, you're multiplying by 1. That doesn't do anything. But the cool thing is that I can rewrite 1 in a way that helps me out, right? Like I know I need to, ultimately I want a 2 in the denominator. And so 1 is, so think about this. I want to multiply by something. I want to multiply by something. And I want it to, I guess the only thing I can multiply by is by 1. Multiplication. What's the opposite of multiplication?
Division. Division.
Turns out that I could write 1 as anything divided by itself. Interesting thing. Multiplication came in is because that's the thing I wanted to do. And we have this nifty fact that if you divide something by itself, it's actually equal to 1. And right at the very beginning, I said, man, if I could just multiply this guy by 2, I would have a common denominator. And so I could say, well, I'm working backwards here, but it's like, that's what I need right there. But 1 can be written as 2 divided by 2. And you stop and say, well, even this first step here, you stop and say, that's stupid. Why would you multiply something by 1? That doesn't do anything. Exactly. We don't want it to do anything. And I could rewrite 1 in a way that helps me out. Because now I could say, well, 1 times 2 is 2. 2 times 2 is 4. And now I have a common denominator, and I haven't changed this at all. Every single step has been exactly the same. This is exactly equal to that, which is exactly equal to that, which is exactly equal to that. They just look different. And now finally I have a common denominator, and I can put them all together, and I finally get 3/4, which was my goal in the first place, right? To write this all with a common denominator. And I did this stupid trick where I multiplied by 1, right? And then I did this other stupid trick where I said, well, 1 is something divided by itself. Okay. Keep this in the back of your mind, because something very similar is about to show up. So let's put it all together. And notice what I'm about to write down is not an equation in the same way. This is not an equation. I'm not going to manipulate both sides of anything. Every step I want to take, every step that I'm going to take, I am going to, everything will be exactly equal to what it was previously, but it's just going to look different. And I'm going to work towards a way of making I want to work towards, of course, in the back of my mind, I know that I'm looking for this type of thing. That's been the whole game all week. We've been talking about, we want to change this into this. And so first thing I notice is it would behoove me to factor out an A. And we just did this. Now, my first step. So this is completing the square. We are going to complete the square. And from now on, whenever I say completing the square or complete the square in order to, do such and such by completing the square, this is exactly what I'm talking about. And and you're going to have to, I'm going to require that you do all of this in each one of these steps the way that I'm about to do it right now. The first step, you're going to hate me for this. This is the first step. You copy this down, just like this. And your very first step is you write this C over here. Trust me on this. This will help you out. That's it. That's step number 1. And what we're doing here is we are forgetting about C. In other words, it's going to come back. We're going to use it. But for right now, it doesn't matter. We don't want to think about it. And we're going to need a little bit of space for what we're about to do. But that C moves further to the right. That's step 1. Step 2, factor out an A from this. Again, we're going to forget about C. We are not playing with C yet. We are going to factor out an A. And so that leaves me what? What's left over from the x squared?
X squared plus
squared. And then what?
Plus b over ax.
B over ax. Now, watch what I'm going to do. I'm going to complete this. I gave myself a lot of room so that I could do this. I'm going to write the parentheses on the sorry. I'm slouching here. Give myself a lot of room right there. Okay. Now, if you remember, this entirely determines a perfect square, right? This, in fact, this right here, just this number determines what I need in order to turn this into a perfect square. What am I missing? This is actually in your homework. You've been, so forgetting about the A out here, forgetting that there's a C right here, just looking at this, if I said, we're missing plus something, what am I missing?
Plus, wow. A squared, right? No. Ah,
How did we do it before? Remember when we had the x squared plus kx? What did we do to this? We took something of it.
divided by 2.
We divided it by 2. So if you have, how do you do
Oh, so b over 2.
b over what?
Two
b over 2?
A.
A. There we go. That is 1/2 of that. Do you believe that?
Yes.
You're like, and in the homework, I said, don't use your brain, just throw a 2 in the denominator. Right? And let's just make sure of that, because we know what needs to happen, right? You're going to have an outer and an inner, and it's going to end up being this plus itself. I'm claiming that this is 1/2 of b over a. Let's just make sure that that's true. Okay. Common denominator means I could do this. B and B is just b plus b. B plus b is how many b's?
2b.
2b. 2b over 2a can be reduced to what?
B over a.
B over a. Okay, yeah. So this feels right. So here's the thing. So you told me that, okay, what are we missing here? What, like, in order to complete a square, I need to add what?
B over 2a squared.
Squared, okay? Squared. Now here's the thing. And this is why I went through that thing with the fractions. We need to add something on, but we don't want to change this. What's the only number I could add to another number and not change the number?
0.
0. So plus 0. But I could write 0 in a way that helps me out. Just like when we could write 1. So what was the opposite of multiplication?
Division.
Division. And we said if we're trying to multiply by something, we could rewrite 1 as something divided by itself. So now if we're adding, we could write 0 as something what itself? So here, this is, I want you to do this. So check this out. So hold up. Multiply by 1 is instead of writing out something, I'm going to write z divided by z. Okay. We want to multiply. So this is the previous thing. Multiply by 1. Remember, that's what we did. We took something and we didn't want to change it, so we multiplied by 1, right? But then we said that that's the same thing, right? So that is multiplying by some number divided by itself, right? This is what I'm saying here. Multiply by 1 is the same thing as multiplying by some number divided by itself. Okay, that's what I'm saying right there. And so now we don't want to multiply by 1. We want to add 0. And we're going to say that's the same as add something by itself. The opposite of multiplication is add. The opposite of multiplication is add. The opposite of, wait, sorry. sorry. Whoa. So when we're dealing with multiplication, the opposite of it is divide. We're dealing with addition. The opposite of addition is what?
Subtraction.
Subtract. So to add 0 to something, you have something and you want to add 0. That is the same thing as taking your thing and adding, well, any number minus itself.
Okay.
And so here's the thing. You think, like, when you see that step, like where I took 1/2 and I multiplied by 1, you go, that's stupid. Why would you ever write multiply by 1? Well, because I could write 1 as 2/2, or 7/7, or pi over pi, or anything over itself. And so that's a real powerful trick you could use in order to change the way something looks without changing its value. Here's another powerful trick you could use. I don't want to change this thing, right? And that's the whole idea, is I don't want to change this thing at all, but I need to add something to it. Well, the only thing I could add to anything without changing it is 0. But the cool thing is the same way that we could write 1 as anything over anything. And we said, hey, that one thing in the bottom is what we really want. We want that 2 to come out. And so we said, well, let's just rewrite 1 as 2/2. Oh, that helped us out. Well, this is the same kind of thing. It's like, we already said it, we need to add in a b/2a quantity squared. I can't just do that willy-nilly. So what I could do is rewrite 0 as the thing that I want minus itself. So that's what I'm about to do right now. I'm going to get rid of all this stuff. It's the same kind of reasoning. It's like, I don't want to change this. And so I'm adding. So the only thing I could add without changing it is 0. But now I could trick the system, basically. I could say, okay, you know what? Here, I'm just copying all this down right now. I need you told me it was b/2a quantity squared. So I'm going to rewrite 0 as the thing that I need, b/2a quantity squared minus itself. Now let's just check. Let me know when you got that written down. All right, give me just a second.
Okay.
Okay. Let's go. Let's check all of these to make sure that this is exactly the same thing as that. So something minus itself is 0. So this is equal to that. Cool. The 0 we don't even need to worry about. The a comes back in. We get an a squared. Yep. A comes back in and kills the a. Yep, leaving me just a b. So that is the same as that. The c is just hanging out on the outside, so it doesn't matter. That plus c, yeah, okay, that is that. This means exactly the same thing as that, but now we've written it in such a way to help us out. And this right here, this part is now equal to what?
Oh gosh.
Remember the whole reason that we did this. Think about your homework, right-hand side, left-hand side of what we've been doing.
I'm confused.
Okay. Remember in your homework when we had something like this. And we said, if we could add this onto here, this turns into something else. And what did you do in your homework?
Divided that number by 2.
And that became what?
B over 2a.
And we said that this entire thing is equal to what?
X plus b over 2a.
And so the whole reason that we added this, right? I mean, like, I could have added any number. I could have added 7. I could have added 45. The reason I chose this number right here, that b over 2a squared, is because I knew that if I added that in, now we would have a perfect square. And like I said at the beginning, don't lose sight of what this means, that once you have that, you can replace this expression with this expression right here. And so this entire bit right there is the same thing as x plus b over 2a quantity squared right there.
Okay.
That makes sense?
Yeah.
Okay. Now, what I'm going to do right now is just make sure, right? We took a new step. Let's make sure that it jives with everything before. I claimed that this thing is equal to this thing. Well, let's just make sure. I'm going to take this thing and actually square it out and see. X plus b over 2a squared is x plus b over 2a. First, outer, inner, last gives me x squared. Inner gives me plus b over 2a x plus b over 2a x plus b over 2a quantity squared. B over 2a plus b over 2a is just b over a. And I mean, we could see that a couple different ways. B over 2a plus b over 2a, factoring out the x. A half of something plus a half of something is 1 of something. This works out to b over a x plus b over 2a squared. And yes, so this thing right there, that x plus b over 2a quantity squared, is the same thing as x squared plus b over ax plus b over 2a squared right there. So that is the idea right there. That is equal to that. It's just a fancy way of writing it. The cool thing is now we have exactly what we've been looking for. This is the form that I've been trying to find. Because now, look at what we have. This is going to be our next step. We're going to bring this a back in. The a is going to jump back into this guy. A x plus b over 2a, quantity squared, minus, this will always pick up a minus, a times that amount, a times b over 2a, quantity squared. Finally, I could drop parentheses. These parentheses will stay with you for those steps. The last thing that comes along is that c. Now, if we're so inclined, we can simplify this a little bit and say that's the same thing as b squared over 4a squared. Minus a times b squared over 4a squared plus c.
Okay.
Which we could rewrite. 1a in the numerator cancels 1a in the denominator. So I'm going to go ahead and try to squeeze that in right here. B squared over 4a plus c. Technically, we're done. I did want to rewrite this one last way. Say a x plus b over 2a squared. I like, and I've said this before, if I have minus and plus, I like to write the plus first, then the minus. So I'm going to write that as plus c minus b squared over 4a. And if I wanted to, I could put this all over a common denominator, multiply the top and the bottom of c by 4a. I'll have 4ac on the top, 4a on the bottom. But what we've just found, look at this. These are just constants. C is just some number. B is just some number. A is just some number. So when you multiply all this stuff out and divide and subtract, this entire thing becomes one number. The b over 2a is just one number. The a is just one number. And so this is exactly the form we were looking for right here. So what I claim, so this right here is what I expect to see. And we're going to do an example of how this is what I wanted to do this in general before we do a specific case, because it will be really good for you to have this written down and in this order. And as you go to work through these, you could have this over on one side of your actual problem that you're working on, and you can kind of look simultaneously to make sure you're doing it right. Now, what I want to do real quick is rewrite this up here, because what we just said, do you have all this? Can I erase this stuff?
Yeah.
Okay. So what I just said is that, let's look at this, that this is equal to that. We didn't change anything. This is equal to that. Yeah, we didn't change anything. This is equal to that. Well, 0 is written in a really stupid looking way, but indeed it is that. That is a perfect square, which is that right there. So nothing has changed yet. This is still equal, and that's equal, that's equal, that's equal. All we did was distribute an a, so that's equal. Now we just multiplied some stuff out and rewrote it in a way that I guess is nice. And so that's equal, that's equal. What I claim is that this thing right there is the same as that. In other words, I claim that this is equal to a x plus b over 2a quantity squared plus, you can think about all of that as one number, c minus b squared over 4a right there. Let's check it. So I'm going to start here and rewrite this as a times this plus c minus b squared over 4a. 6x plus b over 2a, x plus b over 2a. Let me know when you got that written down. Have a hug, buddy. Yeah. Thank you. Thank you.
Plus a plus c minus. Okay.
Okay, so we're wondering, is this thing equal to that thing? This thing is equal to that. I just wrote it as that. So I'm going to say, okay, be careful. We have to multiply all that stuff out first. So see what I did there? I'm using parentheses to my advantage. I'm going to multiply this guy out. Now, first, outer, inner, last. First gives me an x squared. Outer gives me a b over 2ax plus a b over 2ax for a total of, well, 2b over 2ax, or how about just b over ax? So plus b over ax. Last gives me a b over 2a squared, b over 2a times b over 2a, or how about b squared over 4a squared? You buy that? Is that the last? Double check me on that. That is what we get when we do the last of that foiling.
I think so.
Yeah, right? Because b times b comes out to b squared on the top. 2a and 2a should come out to 4a squared on the bottom. Okay. Go. Okay. Now, let's distribute the a back into there and see what happens. A comes in, we get ax squared. What happens when I distribute it into this guy? What's left over?
On ax squared plus bx.
Plus bx. Then plus what?
Oh geez. Plus a b squared over 4. So would it just be b squared over 4a?
Yep, exactly. And I just saw that as the a comes over, a on the top, 2 a's on the bottom. That cancels one of them, leaving me with 1a. Okay, my parentheses are done. I could drop my parentheses. I have a plus c minus, oh, look at that, minus exactly what we picked up right there. That's nice. What does that reduce down to?
Ax squared plus bx plus c.
Holy moly, we got it. This bad boy right there is equal to that guy right there. We did it. We have it. We've figured it out. So now, how is this going to look with an actual example? Let me show you. So you good with this? I can erase this now?
Yeah.
Okay. So if I tell you something like, what was the one we did earlier? The one we saw was a 3. We used an x squared and a 3. Let's do a 2. So let's say we have 2x squared plus 3x plus 1. And I tell you to convert this complete the square to turn this into the form ax plus h squared minus plus k. Oh, and on the homework, I've written these as plus minuses just to say, like, it doesn't matter. Like, I'm not telling you that it has to be something minus something so that it's like minus a negative if it's positive or whatever. I'm just saying, like, you just do whatever's natural, right? Like, if it comes out to be plus, it's fine. If it comes out to be negative, that's fine. Doesn't matter. Don't worry about the signs. So how is this going to look? Well, step one, if you remember, was to rewrite it like this. Step two was factor out the leading coefficient. So that brings a 2 out front. I wrote my parentheses first because I'm just cool like that. That's how I like to do it. And now what's left over on the inside?
X squared plus 3 over 2.
3 over 2x. Okay, now it's not strictly necessary to write the 0, but that's what we're doing. We're adding 0 right here, but we're going to write 0 in a way that helps us out. We're going to write it in a way that helps us complete the square. What are we missing to complete a square right here?
So 3 over 2, 4.
You said plus 3 over 4
Squared, I think.
squared, but I can't just willy-nilly plus something in without changing it. So what do I have to do?
Minus it too.
Minus it as well. And you say, that's stupid. Yeah, it's about as stupid as writing 2 over 2, but it helps us. Now this helps us, right? And if we think back to our homework, we don't have to think too hard about what this square actually is, right? Because it's going to be something either plus or minus something squared. In this case, the first thing in the parentheses is always what?
X.
It's always x. That's why we set it up that way. We chose to factor out that first term so that we're always just dealing with x squared. I'm really sorry about that noise. Man, that's annoying. We're always, so that's part of it. And like I said at the beginning, it's like really easy to do if you factor out that a. And so that's what we did. We factored that guy out. It's always going to be that. Now, is this sign going to be plus or minus?
Plus.
Plus, because this guy is plus. We've done that. And then what goes in here?
3 over 4.
3 over 4. And now this entire bit is exactly equal to that. So I rewrote it. The only thing that's left over is the minus 3 over 4 squared. Okay. Now let's distribute that 2 back in. This is why parentheses are your best friend, and why I demand that you use parentheses here whenever you factor out a leading term.
Mm-hmm.
So the 2 comes back into here, and this is the step where I have seen most students mess up. It's that they'll put the 2 into here, but they won't distribute it over here, and then your final answer is messed up. And so this is really important that we distribute this 2 over here. Now that we've distributed it, the parentheses are gone, and we can have our plus 1. Technically, we're done, but since we have actual numbers, let's see if we can simplify it a little bit more. And so that is as simple as it gets right here. 3/4 squared minus 2 times, what's 3/4 squared?
Hold on, sorry. Finishing writing it down.
Yep, no problem.
9/16.
There we go. We have a 2 on the top, 16 on the bottom, so that seems like we could take care of that pretty easily. How can I rewrite that bad boy?
5, 6, that's 2, x plus 3 over 4 squared, minus 9/8.
There we go. There we go. And now 9/8 and 1 would be nice if we had a common denominator. We'd have minus 9/8 plus, how do I rewrite 1?
Uh, 8/8.
There we go, 8/8. Minus 9/8 plus 8/8 is how many eighths?
17.
Minus 9 plus 8.
Oh, right. 1
Plus 1?
minus 1.
Minus 1/8. Okay, so I'm going to write all of that right here. We have our final answer, 2x plus 3/4, oops, 3/4 squared minus 1/8. I claim that this is exactly equal to that thing right there. I'm going to check it. Can I erase all this work?
Yeah.
Okay, so here we go. So in your homework, I've split up into, so problem 1 is exactly what we just did. Complete the square to write this thing as this thing. Problem 2 says check, which is what we're about to do. You don't need to do all of problem 1 and then do all of problem 2. In fact, it'll probably be better for each one that I give you. You just go ahead, complete the square to get it like that. And then the very next thing you do is check it. And so that'll take care of problem 1 and problem 2. And you can do each one of those together. So now that we've gotten this, I'm checking to see, is this thing actually equal to 2x plus 3/4 squared minus 1/8? And so I'm going to say, okay, 2 times this times itself. Use some brackets to really help myself out. We have x plus 3/4, x plus 3/4. And the previous homework, right? We noticed we did a bunch of these, that whenever we squared something out, right? Like if we have a perfect square, it always comes out to be, I better use hard brackets for that. Just use hard brackets. Keep that consistent. First outer inner last, well, the x is always x squared. Outer inner always turns out to be 2 times that amount. So that's 3/4 times 2 is the same thing as 3/2. So that's plus, since it's plus, 3/2 x. The last turns out to be 3/4 times 3/4, which I could write as 3/4 squared, but I'm going to go ahead and just write as 3/4 times 3/4 is 3 times 3 is 9. Quarters times quarters is 16. And what you'll notice as you go to do these is it's almost as if you're doing the same stuff just in reverse. Interesting. And you'll see a lot of the same numbers that you had before. And you'll notice some stuff. So now the 2 distributes in, and we get 2x squared. What do we get in that second term right there?
3x.
3x plus 2 times 9 over 16 is what?
9 over 8.
Man, that's familiar. Minus 1/8. Okay, 9/8 minus 1/8 is what?
One.
It is 1. It's 8/8, which you jumped way ahead. You jumped like 9 steps ahead and said it's just 1, which you're right. And so, holy moly, this thing is actually equal to that thing. Wow, that's pretty cool. That's pretty cool. The last thing we need to do, and I know we're already 15 minutes past time. So this is what you're going to be doing in your homework. This exact same thing. Notice you're not using like that method that we developed at first with all the A's and the B's and all that. Like you're not just plugging stuff in. That was just to show you what you're going to be doing. And I think now, is this a bit more clear what we're doing now that it's not just A's, B's, and C's?
Yeah.
It is, right? Okay, it's so you get a feel for how this is going to work. Be careful because there's going to be fractions. Look back over your notes when I said to factor out a fraction, but there shouldn't be anything crazy in there. The last thing to do, the very last thing to do, is to find a general solution, a solution to the general thing. And we already said, we just said that this means the same thing as, we proved that this is actually equal to ax plus b over 2a squared plus c minus b squared over 4a. And so if that is equal to that, then to solve this, we just solve this thing equal to 0. So you really should believe that this is exactly the same thing as this. We derived it the hard way, but then we went back and checked it, right? We multiplied all this stuff out. And we saw that, yeah, when you multiply this stuff out, this thing is indeed equal to exactly ax squared plus bx plus c. So to solve this, we just need to solve this. That's what we're going to do. We're going to start ax plus b over 2a quantity squared plus c minus b squared over 4a equals 0. Let's take this over to this side by adding it over here. In fact, this is much like the homework that you just had. We're just going to take this number, subtract it over. It's going to look a little different. We should have a b squared over 4a. What about that c? When I bring the c over, what?
Minus c.
Minus c, right there. Left over here is the a x plus b over 2a squared. Now what I'm going to do right here, because it will be easier to do it this way, I'm going to go ahead and write these guys with a common denominator. And indeed, this is how we could have done that at the beginning here. We really could have. I chose not to. I'm going to say c is the same thing as c times 1. Did you just sneeze?
Jesse did.
God bless you. Now, c is the same thing as c times 1. But I'm going to write 1 in a way that helps me out. So I'm going to take 4a and divide it by itself. Sound familiar? Right? Okay, so this is the same thing as b squared over 4a minus. I'm going to write that as 4 times a times c on the top because I like to have my numbers out front, and then I like to go in alphabetical order. And then we have a 4a on the bottom. And I'm just going to check that, yeah, that's the same thing. The 4a and the 4a cancels. And so that's just a C right there. That's a minus C. It's the same thing. Okay. You got all that?
Uh-huh.
Okay, I'm going to rewrite this. If I were you, I'd be writing this one after another. I'm just trying to say space because I'm going to run out of space. So what I'm going to do is just rewrite all of this with one common denominator. 4a right there. And then how about on the top, I have b squared minus 4ac all together. Is that right?
Yes.
Yeah, I think so, right? And again, we could just kind of double check that real quick. The 4a would go with the b squared. You'd have b squared over 4a, which is what you'd have over there. Yep. The minus 4ac over 4a, the 4a's would cancel. You'd be left with just a c. You would have a minus c, which is what you should have over here. Okay, so we're good. Now we have this. In your homework, what was the next step that you used to solve this bad boy?
Y divided by A.
Divide both sides by a. Exactly. So that gives me an x plus b over 2a quantity squared equals, you tell me what I need to write on the right hand side.
Yeah. Would you right?
The numerator is not going to change. Numerator
4a squared then?
4a squared. If we were so inclined, we could like have a b squared over a and then get rid of that a. That's not really where we're going, especially now that I see 4a squared is something squared. And I know I'm about to be taking a square root, so that's going to be nice. In fact, that is the way I want to write that bad boy, because that will just make things nicer. So I'm going to do that. Now what do we do to solve for x?
Take the square root.
Square root of both sides. And when I take a square root, I get what?
Plus or minus.
Plus or minus. Okay, so now we have x plus b over 2a equals plus or minus. Now watch what I'm going to do. I'm going to say, wait a second. That is a perfect square. 4a squared is something squared. I could rewrite it like this. Like that. And that guy in the denominator reduces down to what?
2a.
Yep, plus or minus the square root of b squared minus 4ac over 2a. Okay, so in fact, I'm gonna save some space here and write that right here. So that's plus or minus the square root of b squared minus 4ac on the top over 2a. Now, how do we get x by itself?
Minus b over 2a.
There we go, giving me x equals what?
B over 2a plus or minus.
Wait, positive b
Oh,
over
wait. No, minus b over 2a.
minus b over 2a
Plus or minus that thing.
the square root of b squared minus 4ac over 2. Now, holy moly, we got this. And one thing you could do almost every single time, I'm going to leave it in this form because it's almost always going to help us out. When we start talking about the geometry of parabolas, this will be very helpful for us to leave it like this. But sometimes it's nice to put it all over one denominator. And hey, look at that. We have a common denominator. And so I could rewrite this entire thing as x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. When I was taking, I think, Algebra 1, it was a quiz grade that we had to sing in class. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And as you can see, it has stuck in my head ever since. So have you seen this before? The quadratic formula?
Oh yeah, we did that all the time in algebra.
Exactly. Now
One.
we have proven that this is indeed the case. Part 3 of your homework. So just to really be clear here, what this means, and we can look at this in 2 different ways, is that this equation has 2 solutions. One of them is x equals negative b over 2a plus the square root of b squared minus 4ac all over 2a. The other one is negative b over 2a minus the square root of b squared minus 4ac all over 2a. If you want, you could have written those with a common denominator, right? Just like we did over here. And in your homework, problem 3 says to check this by taking each one of these and plugging it in for x. And you can use either form that you want. I think it would probably be easier to rewrite these all with one common denominator, although maybe not. So whatever. And one thing to notice though is this way, it's really easy to check in here because just like in your homework, that minus b over 2a is going to cancel with that positive b over 2a, and you'll be left with this and that. Square that bad boy, and it's super easy to check this guy. But what you're going to be checking is this bad boy. And so you are going to take one of these guys, and I'll tell you, it's probably easier to do it like this. To take one of these, plug that guy in for x right there and right there, and just plug along until you get 0 to verify that, yes, it does come out to 0. All right. Any questions? We did it. We got a general solution. Yay. There's a lot to digest. It's a lot of work, but I think your homework, if you don't believe it yet, like you should by the time.
I will believe it after my homework.
You should believe it after your homework, because it's like, I know it was dirty, right? Like the way we did that, like with with taking this and turning it into this, like it's very alien the first time you see it and you think, why am I doing this? But honestly, it's also kind of alien the first time you see this. You're like, why am I multiplying by something over itself? That's stupid. And it's like, well, if you need to change the denominator into a 14, that's a good way of doing it without changing the big thing. There is a much easier way of doing everything that we just did, but it is so detrimental to what you've done. You basically take this equation and manipulate it in a certain way. And I've said 100 times now, we don't want to think about completing the square as something we do to an equation. It's so much in your benefit to be able to do it in place. That is, to take that thing and turn it into something. I mean, it's just like this. There's no equation involved with this type of thing, and it's good to be able to do that. So slightly harder, but the benefits are so you get so many benefits out of doing it the slightly harder way. It's still hard if you do it with an equation, because this stuff is crazy. Like, especially the first time you see it, it's like, why are we doing this? Well, trust me, do the homework and you'll start to see. And I think especially when you check it, you start to really believe it, like, oh yeah, that's what that means. You've just undone this and you've added this. That's what that means. And so, okay,